that you, King Kermuffin?
It is.
Are you back to do more chemistry with me?
For the honor of my favorite band,
Martin. I'm going to clap my flippers.
I will.
Yay. Thanks, King Kermuffin. Will you please read us 11.10?
Yes.
Thanks.
Once again, for the honor of Martin, I will do it in his voice.
Use your Marty voice. That's so cool.
Aren't I nice?
Okay, go ahead.
Martin is very cool. He deserves it. If you wanted to boil a solution made by dissolving 250.0 grams of table sugar, the formula for which is C12H22O11, into 1.3 kilograms of water, to what temperature would you have to raise it? The kb of water is 0.512 degrees Celsius per meter. Molality.
No. Okay. So again, we're going to be using the formula, which is found on page 374. What is that formula, Martin?
Delta T equals I times Kb times molality.
Okay, so let's calculate molality. In order to find molality, we need to have the number of moles of solute divided by the number of kilograms of solvent. Okay, so we know how many grams of the solute we have. So let's figure out how many moles of that we have. So C12 H times 22 and oxygen times 11. So what's carbon is 12, right? So it'd be 144. Okay, and 1.01 and 22. $22.22 and 16 times 11 and 76. Right? We've got 144, 22.22, and 176.0. So we want to report precise to tenths. That's 12, 5, 17, 342.2 grams per mole, or 1 mole.
Moles per gram.
Say that again?
I think moles per gram.
Yes, that's how we're going to multiply this, right? By 1 mole per 342.2 grams. Cancel grams. We'll end up with moles, and that will be 250 divided by 342.2. Martin will use the calculator.
342.2 is 0.7305666919.
Okay, so we have 4 significant digits and 4 significant digits. So we want 4 in our answer. 1, 2, 3, 4. So we'll round that to 0. What?
7306.
And that's what? Moles, right?
Yeah.
Okay. So now we can calculate our molality. Molality is the number of moles of solution, which is, solute, which is this, divided by the kilograms of solvent, which is this. So let's put those numbers in. 0.7306 divided by 1.3.
0.562.
We want to
56.
0.56 molality. So now we're going to look at our formula that we're using. We've got almost everything. So delta T, which is what we're going to calculate, will be I. Oops, we didn't figure out I. Martin, please look at our solute. What kind of a molecular compound is this? Is it covalent or ionic?
It's ionic, covalent.
It is covalent, right? It's completely covalent. So this is only going to dissolve into individual molecules. It's not going to break apart into different ions or molecules. So we have 1 is the answer for I. I is 1. So we're going to say delta T equals 1 times this number, Kb, 0.512 degrees C per molality, times the molality, which is 0.56. So molality will cancel. And after Martin does that calculation, somewhere around 2.5.
It's 0.28672.
Okay, so how many decimal
Celsius.
place? How many significant digits do we want to have?
3, 2.
2, because of 0.56, right?
So that's 0.29
degrees C. Okay, so let's go back to our. What is our solvent?
Water.
Water. So we don't need to be told what its boiling point is. It's 100 degrees Celsius.
So the answer is 100.29 degrees Celsius.
Yeah, 102.9 degrees Celsius. Okay, high five. King, Your Majesty, you are just the most excellent. That was so easy with King Kermuffin.
You're welcome.
Thanks, Your Majesty.
My loyal subject.